so our next speaker is Peter Kim. Peter Kim has a background in epidemiology and biostatistics, as well as data science, and he will speak on the major distinction and similarities between data scientists and biostatisticians. So without further delay, Peter Kim, could you share your screen and begin?
All right. Can you all hear me? Okay.
Yes, we can hear you and we can see your screen.
Yep, we can hear you.
Sounds good. Hold on, just let me. Okay. Hello everybody. This is Peter Kim. Good to be on the last day of the data conference. You learn a lot of stuff. I'm one of the consultants for Amy, Moore Stats. It's really an honor to be a presenter in this conference. I hope I can be a service to provide some of the information about the statistics and data science, biostatistics and data science. So before I start my presentation, I would like to just, do some trivia, to ease the mood and get some interactive time. So I hope this presentation can be like a little bit more fun than a lot of the detail on in-depth of like biostatistics and data science or like AI flow. Just we heard of him, Dr. Patrick Bangor. So I mean, this trivia has no prize at the end, but I hope everybody can participate so we can, just have a little fun. And if you can just type it in the answer, you don't have to yell out, just type it in the answer in the chat box if you know the answer. All right, let's see. So first question is like yes or no, binary question, as we all love binary, right? So big data is explained with the 3 V's, volume, velocity, and VEG. Yes or no? I'll give you 9 seconds to think about, we talk about big data a lot nowadays. Most of my work is related to big data, and I personally think big data is like a hidden treasure, that there's so many unanswered questions that could be answered through the big data and, to find those answers. And I feel like it's like you're trying to find small signals, within a lot of noises and, like a finding a needle on a haystack. So I think, if you have like good methodology or good magnet per se, and, it'll be pretty easy to find that needle, right? So I think that's kind of a big data point that I want to mention. And like, I think there's much more things we can develop in the future within, I think it's like minutes. Sorry, I'll give you like 1 minute. Sorry. Okay. I think so question to answer is that it was no, it was actually volume, velocity, and variety. So you got to have large volume for data, and you got to have processing power to go through the big data, and you got to have a variety of data so you can have different parameters. And I know there's like four V's and 5 V's, and now there's 6 V, 8. So you can add like value, virality, and veracity. Value means does it have a good quality? Veracity is like, is it valid data? Something like that. I personally feel like the VEG can be one of the V's for big data too, because since big data can be, pretty vague sometimes. That's how I think about it. Next question is about the Facebook. So when you're loading the single photos to the Facebook, would it generate the big data? True or false? Meaning when you upload the data photo, would it generate large data that is large enough volume that has a velocity volume and that has a variety of the type, like different type of the data does that generate? I'll give you like 9 seconds to think about. And fun fact about the Facebook, there's like almost 32 billion people are actually like active daily on the Facebook, more than 300 million photos uploaded per day. So that's a lot of photos, so you should think about like how much like data they were generating, like single photo, like, oh, it's a 3 million photos, and you can't, if you have that much of photo generating the big data, would it overwhelm like the capacity or storage of the Facebook they have or something like that? So answer is true, actually. A single photo would generate the large amount of data that we would call the big data, because the posting the one photo is not just the posting just one file of the photo, because when you post it, let's say you posted like 100 megabytes of photo, one single photo, then it goes through the Facebook system, which would go through like filtering tags, different setting they fit into, comments, likes, facial recognition, and even like tracking codes, or that will generate cookies, that will generate, all contribute to creating this big data to the single photos. So do you guys know movie 21? This is from that movie. It's a very famous problem. So on the game show, you've given choice of three. One door is a car, the other is a ghost. So you pick the door number one, and the host knows what's in behind the door, opens the door number three, which has a ghost. And he says, do you want to stay or do you want to switch? So would it be better to switch or stay, and stay where you are? I mean, would it be, does it matter? Doesn't matter if you stay or switch. I'll give you like 9 seconds to think about. So, what he's asking is like, is it better if you switch the door to number two? Would you get the correct price, or not switching with has more chance, you have chance to get the price? So you should think about that. See, there's a three doors. Door number three is already has a code. So you pick the door number one, and you have option to switch to the door number two. So that actually the answer is yes, you will switch. This is very famous Monty Hall problem, classic brain teasers. So basically you would have situation A and B, where situation A, the door number one will be correct, and a situation B where door number one is incorrect. So what we have to think about is what's the probability? What's the chance you would be A or B? So probability of situation A where your door number one is correct is 1 out of 3, right? And then probability of situation B will be 1 minus 1/3, which is 2/3, which is twice likely that you will be in a situation where your door number one is incorrect. So it's always better to switch than staying. But it's not guaranteed, because some game show producer might know this and use like reverse psychology on you, and thinking you would prefer to switching and put the gold on the number two door. Who knows? All right, this is like multiple choice question. Like, it's kind of history question to look at. Like, which mathematician developed the method of the least square in 1809? A. Carl Friedrich Gauss. B. Adrian Marie Legendre. 3. Ronald Fisher. 4. Monty Python. I'll give you like 10 seconds to think about. So it's like, who would develop? I mean, I know many of you might have never heard of any of this mathematician, but like maybe like if you did like a little bit of statistics studying, you heard of Gaussian, Fisher's test, I don't know, Python, you heard of that a little bit. Okay, time's up. And the answer is B, Adrian Murray Legender. I know, like, you heard of the, Carl Gauss, Gaussian based, statistician known for the Gaussian function, Velko normal distribution. Ronald Fisher is known for the Fisher's exact test, and many other contributions. And Monty Python is actually the television show. It's actually a television show, but also the open, source program computer language program called Python. So Python was actually named after this Monty Python television show. So there's a lot of jokes within the Python programming. If you look at the tutorial or something like that, this is an actual picture of the Adrian Murray Legender. He, I think he's looking mad. I think it's because not a lot of people recognize him, famous like Fisher or Gauss. Maybe, many people think of Gauss developed this least square, so maybe he has a frown face. I don't know, maybe. All right, last question. Last question is fill in the blank. It's a sort of easy one if you know your soccer. So Paul the blank was an animal that became famous for accurately predicting the outcome of the 2010 World Cup. What species was a Paul? I'll give you 10 seconds to think about. 2010, Paul the animal was accurately predicted the outcome of the 2010 World Cup. I think some of you are soccer fan, you would know this question. Okay. All right, so the answer was the Paul, the octopus who predicted the 2010 World Cup. If you watch the soccer, you would remember the Paul, the octopus going through this box of the different countries, and he will pick out which one would win the soccer game for the next bracket. All right, so how did you like the questions? Did you guys like the questions? Was it intriguing? And like those questions, I think of statistics and data are, very interesting and also fun, and has history, rich histories, and some riddles. And I think it's in everyday of our life, from social media to sports, just like we saw. My name is Peter Kim, and this is looking at the major distinction and similarity between the data scientists and the biostatisticians. So many of you might heard of it, a lot of, these terminologies. Some of you never heard of biostatistician before. So let me introduce what it is and, what we do. So this is my typical day, what I'll do, just most data analyst, if you're a data analyst or you work at the desk, you're doing a lot of computer, like any other computer gig. So, who am I? Let me just briefly introduce myself before I start. So I major in mathematics in undergrad, and I got master at Cornell with the Biostatistics and Data Science. So this program was a little unique on that because we learn biostatistics along with data science. Not only that, I was under health policy and research in medical school. So what we focus today is focusing on the healthcare field only. And some might think the biostatistics and data science combination is an odd combination. Some might say it's practically the same. So let's look at how they're different and how they're same. So after my master, I was hired by Vanderbilt University Hospital. I did a lot of different work on analysis, work on that part. I worked on the clinical trials, and I did genetic studies, and I had the opportunity to work at the very different with the very different department to work on various projects. I published 2 papers. Other one is coming out, and other one is on the way of reviewing. So over the year, I learned a lot as biostatistician in Vanderbilt. And then I was switched to the Embold Health company, where I was work as a data scientist now. So it was kind of I'll explain later, but like you're switching different job titles, to biostatisticians to the data scientists. Right now, actually, I work as epidemiologist at the Tennessee Department of Health for COVID-19 response team. And then what I do there, is work with the COVID-19 response team to handle data, like data stored. We do a lot of the data manipulation, data automation, so reporting for the state level reporting, and how we handle the vaccination distribution, something like that. That's what I do right now. So, and I decided to talk about kind of this difference between the biostatistics and data science, and not epidemiologists, but just looking at those 2 things, because I had a lot of people ask me the question about what I do, and when I get those kind of questions, I pause and I have to think about the answer. I could say many things, but what am I like? What should I say? The biostatistician? Should I say data scientist? I could just simply say like analyst, but it's like way too broad. They'll ask me, oh, so you do like I don't know, do you do visualization? Like, do you do like a different like Java and C++? Well, I don't know any Java and C++. So it's like, it's way too broad category. And when I say like biostatistician, many people doesn't know and like repeat like, oh, statistician or the biostatistic. So like, that's complicated. And when I say like data scientist, many people say like, oh, Silicon Valley, your IT company, work at the IT company or something like that. Well, there's a side of that, but there's more than that, So who am I really, am I a data scientist, biostatistician, or both? Are they even different or same, So even how they're different. So you have to understand that I'm only talking about in the context of healthcare fields, especially. There's pharmaceuticals, just regular business or banking, financial, insurance, or like AI Samsung or IBM Watson, or different like Amazon. You could work at the Amazon as like different type of titles, or different field. You could work as kind of a weather forecasting, prediction of the weather or something like that. But today I want to just, other than that, I want to focus on the one field that will be healthcare field. And that's where I've been, that's where my backgrounds are. So I think that's the only place I could be more sufficient to explain what it is, what we do. So before I dive in, to compare, you got to see kind of a big pictures, like how many different jobs, we could, like with my degree, could have, what kind of opportunity there is, in the healthcare field. So basically you would have this kind of a skill set. You would have, that's, hazard function right there. And then you would have computer skill like Python and R or SAS, and different analytical skills like methodological skills like doing survival, logical regression, multivariate regression, or you can name anything. So if like hazard function, does it like definite like skill set makes you a biostatistician and like not a data scientist? you know, because some people just do the major in biostatistics and some people just major in data scientists, and they probably, I mean, they would learn it somehow, but like depends on like where program at and where, you know, where you are. You might not necessarily need this hazard survival um, function skills that you would apply to whatever job you're at. You know, so it's something totally different titles like healthcare data analyst, like, you know, you could be like something totally different job you're at, and you don't require, you know, using this kind of functions. What about like Python? Would it defining skill for data scientists? Like everybody has to know, like, or is it for only for data engineer? Like I personally, I don't like use Python a lot, even though I know, but it just depends on where you're at and where what company it is, you know. And also it is combination of things, not just Python, but you gotta know the R, you gotta know the SAS, you gotta know the analytics, statistical testing, and different reporting or processing, you know. So, you know, let's see how big it is, how big will we have, and let's drill down to the very small parts of it. So what kind of career, what kind of job path can I have in the healthcare field? So when I search for my jobs, I did like LinkedIn and Indeed, something like that, or refer by my coworker peers. You know, there's not like other professions, like where let's say you're a clinician, physicians, that you will search for those kind of a specific one. You're, let's say you major specialize in pediatric, you're basically a pediatrician. Um, you're not going to search for like something else. You're not going to search for optometry or something like that. But you know, for us who would study in biostatistics or data science, you would have to do many different kind of searches, because you know you have different options that you could apply to. And as I mentioned, like my department was the health policy and research, which means you would focus on data science um, and the biostatistic, but also you have to focus on the healthcare. Like you could have a different, like you could do something different, like a public, you know, policymakers, like a public health analyst, or you could be epidemiologist who would study disease and where it's come from, what kind of a methodology was a survey or something like to structurize, or do the clinical study, or uh, you could be a healthcare data analyst, simply just do different type of analyzing for different your stakeholders, or you could do like clinical data researcher who are more focused on, you know, building or designing a study for publication or something like that. Or you could do like do statistical analysis in, let's say this is company that would generate revenue by providing some sort of healthcare apps or something like that. Then you would go in there as a statistical analyst who would work to kind of design like what's a good approach to the customer, and then, you know, do different kind of a sensitivity analysis for it could be any whatever product you're generating. You could do like biomedical implementation. So there's different terminologies, different terms that we use to define who we are right now. And you know, from my base, you know, where I'm from, so I did master science, biostatistics and data science, as I said. So it, there's over 30 national master program for data statistics and data science. And there's so many different degrees you could get, you know, MPH, MS. So what is particularly different about those is if you are MPH, then you would Master of Public Health. MS is Master of Science. So MPH program tend to more focus on, like, as I said, there's a public health. So tend to focus on those public health and more focus on the like different methodologies, what kind of different methodology they use. Like And I look at the Vanderbilt master program, and they more focus on inference, like causal inference, regression, survival analysis, like clinical trials, like statistical computing. So those are different, even different type of degree you could get. And not alone with that, you have biometrics, biomedical implementation, um, something, but more different type of degrees you could have. Plus, onto that mix of the program and job terminology, we had a very interesting and significant year, which is 2020. And I feel like 2020 is not over yet. That's how I feel like. I don't know how you guys feel like. But what I meant by 2020 is that we had a coronavirus, and I think I feel like that kind of fueled like the public, to enlighten the public about our side of work. Like before this 2020, I feel like almost most of people didn't know what was pandemic or epidemiologists. Just that's how I felt like. Not a lot of people care about public health. But after 2020, that's what everybody's talking about. Everybody talking about, what does epidemiology do? What is CDC's correspond? What's their policy? How do we have to cope with this? How do we have to respond to this? So there's much more public attention right now. But since a lot of people know about our side, biostatistics and data science and healthcare field and epidemiology, I think it's a good time to recognize public attention and kind of concrete our identity to know who we are and what we could be and what kind of job title we can have. So who is data scientist? I think data scientists in healthcare field, especially in healthcare field, there are people who are like Dr. Vanguard mentioned, they're bridging the gap between. It could be very different from like kind of a technology field or something like that, but in the healthcare field, we're more of data scientists could be doing more of a bridging of gap between the different two professional. I would mention like data engineer to the business sales teams, or stakeholders to data manager or something like that. And we data scientists have a skills of statistic, like from computer science, data engineer. So they kind of sit in this middle of this field to do more practical aspect and know the core parts of applied statistic and methodology statistic, a little bit of a theory, but only kind of a component that actually very useful in day-to-day practice. And they tend to know the component of computer science that are relevant for things like data engineering or algorithm and programming. But they wouldn't like go into details of creating like whole merging the database, like SQL query to pull data, like what data engineers do. And these elements, I think it can be framed as just one, like a title, general data-oriented problem solver. So, that kind of explains it. They're problem solvable, but they're data-oriented. Obviously, this role could be, changing, depend on, who's end up hiring you. They they could ask data scientists who would act more like data engineer and do like big complicated data merge setup from the database, or like data analyst skills. They don't worry so much about the creation of a data structure, but how we collect it, organize, but they care more about, given those structure, how we analyze it and like extract the useful information from it. So it depends on where you work at. Like if you work at, let's say you work at a small company, then they can afford both engineer and analyst. And so you sort of have to do kind of a both work, at the same time. Fun fact about the data scientists, they makes about like 120,000 per month, something like that. And I think most data scientists has a master's degree, almost like 95% graduate found a job since like 2011. So data science to usually utilize, coding skills, like fantastic things. A lot of people think data science only could do like statistical knowledge database with the coding and, but I think there's more than that. There's more than that to data scientists. They could do R and SAS Python and use that to do art, to automation, like AI, just machine learning, just like Dr. Banger just explained, like this is like art made by R programming. Basically, you could do so much more with what your skill set you have as data scientists. And what's a biostatisticians? Well, I think I like the analogy that we, as a biostatistician, we learned at the beginning of the courses. It was the ice cream versus murder. So as ice cream rate goes up, ice cream sales rate goes up, murder rate goes up. So it's a pretty famous analogy, looking at the correlation and causation. But it's not actually the ice cream that's making murder rate goes up. There's a confounder of the heat, where heat would make ice cream sales goes up, and because of all the heat and frustration and kind of the murder rate goes up too. So that's kind of a thing that biostatisticians think about, that looking at those problems and what is the connection, what does it provide? Does it really have a causal inference? Does it have just a correlation between them, and how they're different? So biostatistician, in the line of a lot of doing kind of analytic specifically in the healthcare field. It might be different in the pharmaceutical industry or different kind of CRO, clinical research organization. It might be different, but healthcare field, you would do a lot of analytic plan, a lot of publication, write up of statistical methodology, designing of clinical trials, different design methods for the clinical trial, choosing the right analysis for the study, sample size calculation before going to the design. So all this different type of analysis, instead of where data scientists do more of a computing aspect of automation or something like that. And there's like over 100, more than 100 like biostatistic master programs nationally, I believe. And, so I think it's really kind of a booming at the time, right now, but like not a lot of people, more people, we get more attention, but it's still growing. And because it's kind of has a background from the statistic, it has like two major school of thoughts. One is like frequentist, and one is a Bayesian. You wouldn't separate yourself as like, I'm just frequentist, I don't believe in, I'm a Bayesianist, so I only believe in Bayesians. So in simple terms, frequentist is who more attend to know this randomness around all the analysis. And Bayesian is believing more of a prior knowledge. So you would have prior knowledge that you can apply to current study, and you can use that. And then frequentists only believe in current situation, and there's whatever prior could happen in the randomness. So it's a very simple term that I explained, but there's more deeper understanding of between those two school of thoughts. And biostatistician, another fun fact is like they make average of 90,000 per year. I don't know why it's lower than data scientists, but it seems just a little bit lower, more or less data collected. I don't know. But we do a lot of population related or causal related inferences and kind of building a conceptual model, or setting kind of different assumptions, So biostatistician is in that kind of a form of like statisticians, but within like healthcare field, or more closer counter to how the interpretation might be different for a statistician, where they're handling bigger, larger data set. I mean, it's not like we don't use a large data set, but like most of machine learning or data mining, it'd be like very different from us, from the biostatistics. And then, there's two things you can go into, like non-health and health in biostatistic, as statistic. And I think health statistic is basically biostatistic. And when you go in that route, instead of going into the non-health where insurance company or financial, Anthem, Cigna, but you can go into the path of healthcare field, where you would do most of your work is either looking at the appropriateness or effectiveness. So basically, this different procedure or medication, does it appropriateness to the patients, appropriateness to, was it effective to the patient? How can we systematically change the policy, or make a manuscript to change to apply to the physician to do different, like instead of doing the surgery, do the physical therapy, because it's a much less, more effective and less inappropriate. So something like that. You would do like time to time, you would do like cost effectiveness analysis. I think that's also like close counter to the effectiveness, is you're looking at the effectiveness of, financial problem within the hospital. And, the surgery would cost so much more compared to, doing the physical therapy. So even though I explain a lot, and, there's a hint, when I was explaining what is data scientist and biostatistician, this is different, that is different. What's actually different, and what is same, what is unique between apart from the data science, what's apart from the biostatistician. So I like, what's the similarity? I like to use analogy of D&D, Dungeons and Dragons. You guys know Dungeons and Dragons? Maybe not. So there's knight who could do certain things, like they would fight with the sword, and do wear armors and something like that. And there's a wizard who would do certain things, like they use magic, they kind of do support, something like that. Well, like let's say you're paladin, or who can do both, who can do. It might be not correct analogies that just because I don't know much of D&D, but that's what I think. The both biostatistician and data science, they could do has ability of utilize both kind of statistical hat and the computational hat, and kind of one side you would have a kind of a clinical understanding of how this approach has to come out, and on another side of it, more of a computational or kind of different statistical methodology, where you would apply the number and data, and what you can, the limits of it, what's the limitation, what's the assumption, what kind of analysis you can do. And both data scientists and biostatistician can do those kind of things. Like Dr. Banger mentioned, I think it's important that the communication. So those communication is very coming the place for importance in job role of the biostatisticians and data scientists. I believe that is kind of a big similarities that I want to mention. And I mean, there's other similarities, like if you're a biostatistician, you would still work on like creating the automation for different type of processes like clinical trial. You would do some visualization automation that would create monthly or weekly that would generate to publication or to the stakeholder to review those clinical trial process. Or at the same time, data scientists would do those kind of automation because in their nature, they do a lot of automation. And then same with the data scientist, they would do kind of a looking at towards smearing, because they have to apply that, and they'll go into the studying towards smearing and know the application. Obviously, biostatistician know where it has to be in place. It has to know what to do in smearing, has to do with it, you know, to apply that, oh, there's a log logarithmic, so you gotta account for that, just weight it. You gotta weight those change in cost or something like that. So I think those are big like difference. And you know, there's the differences. I mean, similarity, different. So there's the differences. So differences is, I think the data science more focused on kind of a data manipulation, cleaning, kind of visualization, more automation. So they would do those kind of work 70 to 80% of the time, where their effort to work on 20% to 30% of their time would be working on different type of methods they could use. As I mentioned, like doing smearing or something like that, they would, if I want to apply it, can I apply it? Like, how do I apply it or something like that? More practical approach than biostatistics. So I think 70% is more of a practical side, where 20% is more of a method and theoretical stand. Where biostatistics, biostatistician, is like they know practice. So they're I would say 50% of practical terminology or communication or something like that, and then other half will be you're studying. You could be either writing up, and then to write up some analytical plan or some clinical trials, you got to know the background of how the disease or what kind of concept you're working on. Like, let's say you're working on the risk factor, looking at the risk factor of the shoulder surgery, then you got to know the backgrounds of it. You got to know what kind of a limitation and assumption there are. So you got to be more flexible and understand and know how to adjust your approach within the context. Within the context, you're you know, when you're talking to the clinician, when you're talking to the statisticians, you know, to bridge that kind of interpretations. So I think like biostatisticians more tend to work with a lot of physicians, not like data scientists work with the physicians, but like maybe not directly. They will go through some sort of data manager to the clinician or something like that. I think that's a kind of big difference that I felt when I was working as a biostatistician and data scientist. Of course, this view is kind of limited to what my view, and it can be very different case by case. As I mentioned, where you work at and your role in the company and hospital can be changed. So my personal experience would be that I mentioned the health policy research. I have a computer skill, R, Python, SAS, SQLs. So I can do like many different analysis, like survival, longitudinal, multivariate, mixed model, regression, logistics, something like that. So what I did in Vanderbilt, I had this great mentor, the Frank Harrells, who were the biostatisticians, and I work at the physical medicine rehabilitation, where we would focus on working on more of shoulder surgery versus physical therapy. At the time, I was working at the working with a big clinical trial, MultiCenter Clinical Trial. So as a biostatistician, where I work at the Vanderbilt, I did a lot of I did randomization for the clinical trial. I did I worked as a kind of a data manager for the clinical trial because I was kind of a main person who would control the clinical trial data and how it has to be managed. It's just like I mentioned previously, I have to create the visualization or tables to stakeholders to review. It was a 5-year study, so we had to review like monthly or quarterly, how is the process, how we can change or manage the studies. And I published the paper, as I mentioned, and those paper would looking at like risk factors of BMI versus kind of BMI versus shoulder tears. Like would shoulder tear would more frequently happen to the higher BMI, lower BMI? How is the difference? So we would do, I would do a lot of analysis on mixed model, and then there's data, like it's not like crazy large data. So you'll look at the multiple like imputations, or do the missingness analysis or survival analysis, even like cost effective analysis. I did that at the Vanderbilt. And then other side of it, that when I switched to data scientist at the Embold, I did a lot different thing. I mean, some are similar, but I did mostly work at the visualization. Embold is a company that we would provide the score for doctors. Basically, we're scoring doctor. You're a good doctor or bad doctor. And well, you can't really say that like directly, but you would give some sort of a score to each portion of it, like appropriateness, effectiveness, or cost of it in each different domains. And what I did was, as I was data scientist department, I did a lot of visualization as how we can show the data to the stakeholders so they can understand it, or data managers to understand what we're doing it. And the other part, like 30% of it, I work on the model. Like we would, there's a calculation, statistical calculation that we put it into to score these doctors. We would use insurance claim and hospital record to create these scores using, we use MCGLMM, which is, I think I mentioned previously about Monte Carlo, Markov chains, generalized linear model that would use this kind of a statistical model to provide these scores, to estimate those scores. And I work on the setting up the prior, even though I didn't know like everything about it, I would work with the scientific advisor to kind of or other statisticians would come in to help me to build this model, or working on the prior if I'm missing any particular evaluation of prior studies, or if I did wrong on the different part of a prior data set, like how I did calculation was wrong, or parameter or setting is wrong, they would come in and help me with it. So, you would, have help with this different external, like statistician, to build this model. So that's what I did as a data scientist and at Embold. So you can see like it's very different from where your company, where you're at, like what you get, like as a clinical study. It's a, it's just a private sector company. But then you still have to those statistical computing that you use R or SAS, Python. You do the same thing. Right now, I do COVID-19, data steward. I would do 80 to 90% of my time. I would focus on data processing on COVID-19. There's a flood of data in all the Tennessee state, and then I would basically generate automation process. Basically, we would different parts of the, we have to distribute data and vaccination data distribution, and positive cases and missing cases, different counties or different state or different policies, and there's different departments that we have to process. And basically what I'm doing is a building a process, so kind of a flow through, like automatically. It's not like, it's not going to like end it like, oh, it's a done, like you can just click and it's done. But like it's in the process of building those kind of automation process. Like more than half part of it is done, but like you still have to adjust like new kind of a development or like kind of a new kind of request to come in, and you have to provide a, like Vanderbilt ask, can you upload like weekly to the Red Cab to provide a rate of certain things and certain positive negative case of what's new death, new cases, something, was there a cluster between the facilities, and we have to investigate onto those facilities and how to process those data, kind of stuff like that. So that's what I do now, but not as biostatistician and data scientist, but it's similar to what they do and somewhat different than what they actually do. So you would have similar things that you would do as a biostatistician and data scientist, but in the core, your skill set are same, but in the structure and the surface, that what your project were meant to do or what you have to know for your focus on certain project, it would be very different. So I think, what to take away from all what I said is that you should know, even all this changing environment that, I think that we currently have like really quick changing in our current career in the job market. And I think one thing I can promise is that one thing I can predict is that, what we have in data analysts, what we have as data scientists, biostatistician, biostatistic, I think we have great futures. I think we have very promising career that you could not just flourish within healthcare. I think it can change the world and change the policy, and we can prevent or fight with the next pandemic, because we don't know when its next pandemic is going to come. And I think we would make a difference within that. And I think as healthcare data analysts, you will always need it more than ever. All right, thank you for listening to my presentation. I hope it was kind of fun and interesting. Thank you.
Thank you very much, Peter. Thank you. That was that was a lot. You gave us a lot of information. I personally know that, salaries tend to vary.
Yeah.
Right?
Yeah.
If you're a director of a department, you may be paid more than the mean, right?
Yeah, obviously, but it was just average.
Yeah. So which one do you prefer? Do you prefer
another reason data scientists and biostatistician, the salary is different, is because data scientists tend to more into not only healthcare, but also in like financials and a lot of IT,
right,
where they would pay much more than where they biostatistician, where they're academic or hospital or government, they would pay less than, because they don't have that much a budget,
What about in terms of education? I know with biostatisticians, some stop at master level degree, others go on to the doctoral level. Mm-hmm. For data science, how is it? What is the requirement there for education?
Actually, I looked it up, and data science majors, they tend to not go too far to behind the master. Not a lot of people get PhD, but I think the trend is changing because there's a lot more people getting masters. So if I personally believe all the biostatisticians, all the analysts, all the data science, they should be the leader because they know what's focus, what's important. They know how to interpret things easily. So I think they're meant to be a leader. And I think to be on that position, I think you do need some sort of education. And I think getting a PhD might help. But still, I think we're still at the time master is enough. And I think doing the master, I think bachelor is a little bit, I mean, I didn't do bachelor in like stat or data science. So I don't know how they would do it. But when I got mathematics, I would only had the bare minimum, exposure to those kind of area. And I had no idea how it would be different and how it would be kind of a practical term. We didn't learn that because the bachelor was more focused on what's knowledge there, like what you have to know or terminology or like conceptual understanding. But when I did master, I did like capstone project, I did my thesis, and it was more of kind of working side by side the biostatistician to have a practical experience and practical skill sets. Like Dr. Banger explained that, even though there's a difference that what you learn in school and actual industry, it's a different, like basically master will give you that exposure to get in the industry. At the same time, you could have a trial and error kind of experience to strengthen your skills. And then after that, you're probably more set to go into the industry and you have more confidence in what you know than just having a bachelor degree. And a lot of company kind of support that, like especially in like academic field, that would offer taking different classes, that master classes, and eventually ended up getting to the master.
Right. Thank you for your presentation. I felt that it was really unique. I like the slides about the art. Yes, and how that you can do that with AI. Yes, that was great.
Super kind of in depth, like super terminal, like conceptual stuff. So
that was great. So, are there any questions from the audience? Anyone?
I have a question, and I don't know, if you can answer it or not. But when you're looking at job descriptions out there, and I'm coming from an accounting background, I've got a bachelor's degree in that, and I'm working on my master's in data analytics right now.
Mm-hmm.
So on one hand, I feel like I wouldn't want to be considered entry level, but on the other hand, I don't have the analytics experience.
Yeah.
So what is your suggestion on, getting your foot in the door? Because a lot of places say, 2 to 5 years experience to get in.
Yeah, I mean, I think it depends on where you're at with the master. Like, let's say you're like full-time student and you don't have a lot of time, side time where you could do, get the experience. But while I was doing the master, I actually worked at the hospital as a biostatistician, kind of internship. So that looking at those kind of internship would help alongside. I mean, you should talk to your advisor to if there's any opportunity that I could approach with the different company around you, or if you're accounting and data analytic, that you could look for around internship around the area and see if you could do kind of an internship or kind of internship program, and that would kind of help you have that experience while you're doing the master. And a lot of people actually work while they're doing the master. So it depends on the master. If your master program is really intense, like let's say it's a 1-year program and then they just push everything, squeeze everything to in the 1 year, and you don't have time to do anything except doing the full time, obviously you can't. But if it's a like 2 year and it's kind of flexible and you can actually work or do the internship on the side, definitely do it. If it's not too much. So it just depends on, what your strengths are, if you can do the both, so it just depends. But I think it's a really good opportunity to do that kind of an internship, to kind of set your foot in and it's all about, I don't want to say this, but you got to have some sort of a reference, and you got to have some sort of a connection to go in that field. So if you do the internship, it's most likely they would prefer you to the different places, or prefer you to different opportunity within the company or something like that. Does that answer your question?
Yes, thank you.
Any other question?
Are there any other questions? Yeah, I just want to say very quickly, I'm a biostatistician. So I think Peter will agree with this. The way that I got in is I took a role that wasn't necessarily biostat statistics, but it was related to it. So that's how I got in to the field, right? Because at the time I didn't have the master's degree, so that's how I got in. But then once you're in the organization and you get to know people, you'll see who the players are.
Yeah.
So I hope that answers.
That kind of give you sense of like, what do you want to do? Like, oh, I don't like what I do in the internship, then definitely you would search for something else in the, after the master. And that's what I did. I didn't really like too much like what I did at the hospital. So I ended up searching for different places.
Okay. Well, thank you for that talk. I think it was very insightful, and I'm sure everyone appreciated it. So now we're going to go to the next speaker. Yes, thank you very much, Peter.